quantum mechanical computation.
Did that scare you?
Well, the fusion of these two moderately complex subjects seem to flabbergast many and further complexity by face value. The computers we have today are incredibly powerful, but some tasks take way too long, or just don't work. That's why scientists are looking towards the quantum computer, to make those calculations that normal computers can't make. Before looking at quantum computers, let's first see how traditional computers work.
Every computer has a CPU, a central processing unit. The CPU contains basic modules, which contain logic gates, which are made up of transistors. The transistor, being the smallest data processor, is a switch that can open or block the pathway for information in the form of electrons to get through. Today, the typical scale for a transistor is 14 nanometers, which is really small. The information comes in the form of bits, which are either set to 0 or 1. We can combine bits to make larger, more complex forms of information in binary. In quantum computers, we see the use of qubits, which are similar to traditional bits, but their functionalities are like night and day. Similar to regular bits, qubits use zeros and ones to determine the information, but a qubit state can also be both of those at the same time.
It's kind of trippy, but to demonstrate this, let's say that a bit is like this coin.
It can either be heads or tails, right? Wrong. If I toss the coin in the air, we see that the coin is in a sort of undetermined state. In a weird way, it's heads and tails at the same time. It remains in this undetermined state until it collapses in my hand and I observe it. This idea of being all cases at the same time until observed is called superposition, and is exactly what happens with qubits. Now, why does any of this matter? You're Harry Potter in the Goblet of Fire, and you need to traverse this enormous maze to find the Triwizard Cup. Instead of aimlessly running into the maze, you're smart enough to hack your computer, which will bring you one traditional computer or one quantum computer. If you decide to use the traditional computer, it would have you linearly search every single route until it found the correct route. This could take ages. The quantum computer could just traverse all the routes at once, and then find the correct route using a filtering operation called Grover's algorithm. Or you could have just Accio the Triwizard Cup to yourself. But it's okay. The point is, quantum computers make enormous calculations in absurdly low amounts of time by executing all scenarios at once.
One note of caution though, don't expect quantum computers to be implanted in your day-to-day devices. One of the main uses for quantum computing is quantum modeling, because of the immense resources needed to render such models. Your run-of-the-mill laptop does not need that much computing power to function properly, unless you're trying to hack into your ex's Netflix account, in which case, you do you, boo. Imagine if quantum computers had AI abilities, the ability to build other things, or maybe even reprogram themselves. When given a task with parameters, the computer could try a plethora of circuit designs and programs to make the most superior builds. Who knows? Maybe if we terminated the parameters, we could even end up with the Terminator. But because this field of study remains untapped, it's up to our future breakthrough geniuses to guide the path. This has been Sid, and thank you for your time.